Hey there, geometry. We are in Unit 7, all about circles. I love circles. They're so uniform. It's amazing. All right, so let's start out with this notice and wonder. Lines and angles. It's our warm-up. So your student task statement is, what do you notice? What do you wonder? And like I always say, these are the best to do in class in person because I get to hear all of your ideas. And it doesn't matter what they all have relevance. So I see 3 circles. I see, let's highlight, why not? Let's highlight in green. This one has a center. This one has a center. This one, I think that's the center. Okay, I don't like how that green turned out. So let's try markers. This one has a center and no radii. Like that's not a radius because it's not from the actual center of the circle to the edge. Okay, this one has a center and these are all radii. Radii is plural for radius. So radii. And if you see, I also have a diameter here. Right? Diameter goes from one edge to the other and through the center. This one has a center and it looks like I have radii or diameters. I should have done that in blue. Another diameter or 2 radii, but like what are those? Seriously. I wonder what those are. I don't know what to call them. I mean, if it goes from one edge to another, it's not a radius. That went too far, sorry. But like I don't even know what to do with that, right? So that's what I notice. That's what I wonder. Okay. Ooh, I don't know what just happened there. So the defining moment. Let's change colors here. All right. I had to pause for a minute. I'm not sure what I said beforehand, so here we are. The defining moment, the student task statement says, the images show some line segments that are chords and some segments, why isn't it writing, that are not chords. All right? So a chord is something that has endpoints on the circle, and that's it. That's the definition. Endpoints on the circle. Endpoints on the circle, and it's inside the circle. Okay, so it's a line segment with endpoints on the circle. Here, not chords. Okay, that's not even inside a circle. This has one endpoint on the circle and one endpoint in the center of the circle, not a chord. This one has, it's outside the circle. The endpoints are not on the circle itself, all right? So if I wanted to write a definition of a chord, what would I write? All right, I'm gonna get the technical definition because I really like the technical definition. So the definition of a chord is a segment whose endpoints are on a circle. That's good penmanship there. Okay, so that's my definition of a chord. Now here we have images that show some highlighted objects that are arcs and some highlighted objects that are not arcs. So here, an arc, I have 2 endpoints and a part of a circle, right? 2 endpoints and a part of a circle. 2 endpoints and a part of a circle, right? Okay, not arcs. That looks like a parabola. I don't know what to do with that. Okay, but it's not 2 endpoints on a circle. And here, that's a chord. Okay, a chord is not an arc, right? So let's write a definition of an arc. The portion of a circle enclosed, need more space, between 2 endpoints. It's great penmanship again. There we go. Between 2 endpoints. So that is the definition of an arc. Now let's talk about central angles. So some angles that are central angles and some that are not. So if I look at these are all central angles, and it looks like the vertex is the center and the endpoints are on the circle. Vertex is center, endpoints on the circle. Vertex is center, even if it's a straight line, endpoints on the circle. Now here, this vertex is on the circle, not in the center. Like, that's cool, but that is not cool. Okay, again, cool, not cool. Cool, not cool. So it looks like the vertex of the angle has to be in the center, right? So if we write a definition, the central angle is an angle. With its, oh my goodness, vertex, I should just slow down, at a circle's center. Okay? So that's the definition of a central angle. All right, so let's try to use that in some way. 1 second. Okay, I'm back. So this third task statement talks about arcs, chords, and central angles. Okay, so we look here. I've got a circle. Looks like I have a straight line, a diameter through it. This is 60 degrees. Do you guys know what the inside of a circle's degrees are? So an entire circle is 360 degrees. A half a circle is 180 degrees. So here, let's do the highlighter again. That's a straight line. It's a diameter. It goes through the center and it touches C and B. So that splits the circle into even pieces, 180 degrees, both halves. That means that this is 180 degrees. That's 60, therefore this is 120. Because 120 plus 60 is 180. Right? Okay. Not even sure that's what I was supposed to teach you at that point, but it made sense to go over it. All right. Yep. Looking at my notes. Yep. And yep. Cool. We got everything we need to do on that little image. So let's talk about this one. So this image shows a circle with two congruent chords. That means the distance from E to D is the same as the distance from C to B. Okay, so draw the central angles associated with the highlighted arcs from D to E and B to C. Okay, 1 second. I'm going to go check our curriculum to see if we have an applet for that. No applet. All right, so draw the central angles associated with the highlighted arcs from D to E and B to C. So we're going to go a straight line from E to A and a straight line from A to D. So that right there is our central angle. And I can, well, it's okay. Let's change colors. We're going to go from A to C and A to B. And that is that central angle. How do the measures of the two central angles appear to compare? Prove that this observation is true. All right, it's actually, they appear to be equal. So I can say that angle EAD appears to be congruent to angle BAC. To prove this, you would grab your compass, or maybe your protractor, and do some measuring. Okay? Measure those angles. But I can tell you that when you have the same size chord, okay, this, well, we'll do 2 ticks. The central angles are congruent. All right? What does this tell you about the measures of the highlighted arcs from D to E and B to C? Well, what's really cool there is this arc is congruent to that arc. So when your central angles are congruent, your chords are congruent, and your arcs are congruent. Okay, those are all connected as long as it's a central angle. It has to be a central angle. Cool. Let me make sure I didn't miss anything. I think I might have glossed that at a high level. Ooh, really important. Sorry. I know that this is equal and that is equal because they are radii. Okay, that's important. So that's how we prove it. Silly me. Let me switch to something red. Okay, these are equal and these are equal. And it already says that DE, I can't use 1 tick. I guess I should use 4. Those triangles are congruent. Triangle AED is congruent to triangle AED, I'll say ABC because of side, side, side. We learned that a long time ago, didn't we? So those are congruent. Therefore, angle EAD is congruent to angle BAC because of congruent parts of congruent triangles are congruent, CPCTC. So we know those interior angles are congruent, okay? We also know that they're isosceles because 2 sides are congruent, but we're not doing that right now. So side, side, side tells us that those triangles are congruent, therefore the angles are congruent because of CPCTC. Okay. 3, the central angles that are defined by these are congruent. The arc measures are the same as the angle measures, so the measures of the arcs must be equal. Okay? Cool. All right, here is just another little example. I know that A to C is a radius, A to B is a radius, A to D is a radius, A to E is a radius. All right? I know that those 2 angles are congruent. Therefore, triangle ABC is congruent to triangle AED. Therefore, I can say BC is congruent to DE. Because of CPCTC. I can also say that this angle is equal to that angle, this angle is equal to this angle, etc. Because the triangles are congruent, everything's congruent, okay? Oh, and very important, this arc is congruent to this arc, okay? That's just something we've now proven. Cool. More. Ooh, what's really cool here is I have 180 degrees because that is a diameter. Therefore, let's see, this is congruent to this. I should use 2 tick marks. That's congruent to that. What else? Oh, here's another radius. Therefore, we can say the triangles are congruent because of side, side, side. Therefore, we know that this central angle is also 50 degrees because of CPCTC, right? 180 minus 50 is 80. Therefore, we know this is 80 degrees, and our arc is also 80 degrees. Okay? 50 degrees, 50 degrees, 180 degrees, 180 degrees. So many things we know. Let's see if we've learned anything else. I think that's it. You are done with lesson 1 of Unit 7 circles. Good job.